The control cabinet was prepared last time, but there is still a lot to do. I 3D printed some custom cable glands for the motor encoder cables. There it goes, the encoder cable. And all the other servo motor connections. There goes the operator panel, which was prepared some videos ago. The link to that video should appear somewhere in the corner. I prepared also a little mess, which I would like not to discuss about. But trust me, everything is according to the wiring diagram I prepared. I can't explain that, but I would like to mention there are the screws which hold it down on the frame. I would like to say the panel will be connected through 4 cables to the control cabinet, but I would be lying. To be exact, it will be 6, about 70 wires overall. I connect the CNC controller to the breakout boards using the ribbon cables. And not to forget the Ethernet cable to the PC. I 3D printed also this cover. It will be defending the panel from the chips flying around. Wait a second. There we go. Wanna supply some energy to it? First, the breakers. And fire in the hole. So, the machine starts in reset mode. Let's test what is available right now. Firstly, the clockwise and the counterclockwise spindle movement. The relays seem to work. The spindle can work in speed or position mode, thanks to all the relays inside the smaller cabinet. The SRO knob will be really useful. It allows to adjust smoothly the RPM on the spindle. There is also a coolant button, but physically coolant will be added later. And the light switch. 2 USB ports connected straight to the PC. And the tailstock area. Not connected yet, but prepared. The pushing force will be adjusted here. The locking system and manual on-off control will be available here. Green button for cycle start. Red one for cycle stop. And the e-stop. To maintain a minimum amount of safety. And the MPG. It's my first machine which will be equipped with this beauty. There is also the FRO knob, for smooth adjustment of feed rate during the work. And the feed hold button. Zeroing buttons, homing and limit override. And all of the jogging buttons. For example, when the spindle is not in speed mode, then I can turn it freely as the C-axis of the machine. It also keeps its position in position mode. Thanks to that, it will hold still when changing the workpiece. Thanks to the 1-to-1 ratio, I can use the Z signal of the servo to home it. After each operation, it can go back to the home position. Might be useful. Of course, all the other axes can be controlled by the MPG too. It is always important to do it carefully and safely though. No, fuck! The keyboard I will be using is not prone to electrical noise. I've had to 3D print a spacer. Weirdly, when a spacer is applied, it works fine. Maybe a wireless keyboard wasn't the best idea, but it was the most compact one I've found. Yes, I'm connecting a wireless keyboard. Brilliant. Now regarding the servo tuning. As far as I know, these servos don't have auto-tune functionality. Firstly, I set the load inertia ratio. Trial and error method here. At 100 it feels quite flimsy. Lower value is even more flimsy. And it goes into resonance real easily. I was trying here to stop it, switching between speed and position modes, but every time it was getting back to the resonating state. I had to change the parameter. At 150 it feels better, more rigid and doesn't resonate anymore. I hit the sweet spot at 260, where it seems to be even more rigid and no resonance. I tried 400 too, but over 300 it started to vibrate weirdly. Now the second parameter to set is the speed gain. The higher, the more rigid. At 20 it seems to be very flimsy. At 50 it's getting better. I raised it to 80, but it started to vibrate. So I left it at 50. Next is the speed integral time. Decreasing it should make it more responsive, increasing it should help suppress vibration and overshooting. If I remember correctly, I left it at the default value. The last one is position loop gain. This setting sets the responsiveness at holding the position. I tried it at different values, but it seemed that it didn't change much, but I had the feeling that the servo is starting to overshoot at higher values. So I left it at 50. These are all the tuning parameters. I set them at the values I felt it worked the best. I was trying to follow the instructions from the manual. Overall, at this point I'm happy with it. We'll see how it will perform under working conditions, during cutting. I also tuned a bit the axis servos. At the axis, I set just the position loop gain parameter. Lower value, less stiffness. Higher, more stiffness. But I was keeping in mind too high could lead to vibrations. I left it on 100, both for the Z and X axis. If needed, I will adjust it in the future. Different setting comparison. On the other hand, I prepared also some covers for the X axis. I added them to the whole assembly in ZW3D. Thanks to that I could easily design some holding brackets. Some of them are going to be made of steel and the rest will be 3D printed. One side will be located a bit higher due to the motor at the end of the bolt screw. And so I did. I made some drawings and went straight to the metalwork. And there goes the drilling. Tapping. Welding. And assembling. And of course, testing. There are still many things to improve and to do. If you enjoyed, make sure to subscribe so you don't miss the next part of this build. Thanks for watching.